Recording. Okay. So again, thank you everybody for coming today, and this is, I think, the first time I'm doing this presentation publicly, so a bit exciting, and we're excited today to talk about a robotics sensors and motor training kit that Studica is beginning to offer, and take a look at that, and we'll go through some demos and basically give you a picture of what we're talking about today. And my name is Mark Phillip, and I'm an application engineer with Studica Incorporated, and we'll talk a bit more about who Studica is here in a second, but if you need to contact me for any reason, my contact information is markp@studica.com. You can also see our website at www.studica.com. So some of you may or may not know who we are, but basically Studica is a robotics manufacturer and distributor for education, and we are a global partner with World Skills International and work with the mobile robotics competition, so World Skills Robotics, or WSR is the acronym. And basically the motivation for today is that we saw a need for a product that teaches robotics and controls using LabVIEW alongside the MyRio device from National Instruments. And this program we're talking about is suitable for higher education as well as robotics competition teams that use LabVIEW, so World Skills Robotics, WRO, and First Robotics, for instance. The product is basically going to train in the use of sensors, motors, and actuators. And what the product is actually called on our website is the WSR Sensor and Motor Training Bundle for MyRio and LabVIEW. So we're basically going to look at some of this and kind of give you a big picture of what this is all about. So to start off, we'll take a look at what is the Studica WSR Sensor Motor Training Board. And we have a picture here on the right, which is showing us the sensor board that we have hooked up to the NI MyRio right here. So again, to kind of reiterate, we noticed that there was a need for some kind of tool that taught LabVIEW along with control of sensors, motors, and actuators. So this is kind of there to fill that niche. Now, what's included with this kit, this picture on the right here is essentially what comes with the kit, at least that I've received. So we have the sensor board and the motor board along with the power supplies for everything and the ribbon cables. So again, you get the sensor board, the motor board, you will get Courseware with exercises, which we'll discuss more about the Courseware here in a moment. And there's two different bundles, and this is important to point out. One bundle includes the MyRio and LabVIEW, and the other one does not. So if you don't currently have a MyRio or LabVIEW, then you'll want to get the bundle that includes those items. Otherwise, if you have MyRio and LabVIEW, you should be able to just get the bundle that does not include those. However, there's some caveats here with LabVIEW. If you have a student license for LabVIEW, that's not going to work because you need to have access to the real-time module and MyRio toolkit, which are not included with the student license. However, a university site license does have access to these tools. So the main thing here is if you have LabVIEW student, you're probably going to need to get the package that contains LabVIEW and MyRio, or not probably, you will have to get that package because you need those tools. But if you have a university license, you should be okay on the LabVIEW side of things, but you also need a MyRio. Now, first we're going to take a look at what the sensor board is, and we have basically a list of all of the different sensors on this board, and then the picture here on the right shows you what the board actually looks like. And I'll just kind of hit some of the ones that I think are big, but we have like an IR sensor here, ultrasonic sensor, there's a 5-volt relay, there's a toggle switch, there's a 2D rocker here, there's a buzzer, there's also some PWM controlled LEDs, and yeah, there's a lot of different sensors on this board. We even have an IMU, so a 3-axis gyroscope with an accelerometer and a magnetometer. So a lot of different tools here at your disposal to really explore controls solutions, as well as introduce you maybe to this field, as well as this can be a great tool for just furthering research and doing data analysis and things like that using sensors. So yeah, it's a very versatile tool. And we also have a motor board in the kit, and the motor board looks like this. We have just a bunch of different motors and servos on here. So we have a stepper motor drive circuit, a hybrid stepper motor, a DC motor drive circuit, a DC speed reduction motor. We also have a PWM controlled analog servo motor and a solenoid valve electromagnet drive circuit and a 7-segment LED display digital tube. So the idea here is to really just explore the technology behind all of these different motors. And in the courseware, it will discuss, what do you use these different motors for? How do they differ from one another? And it will talk about some of the theory behind, how you control some of these. For instance, with PWM, it will talk about what is pulse width modulation and all that. So again, the idea is to really explore these concepts, figure out how to control these drives, and again, it can also be used for research and interesting projects. There's a lot of versatility here with having so many motors in one place. You can really do a lot with it. Now I want to talk about the courseware that's included. The courseware is very comprehensive, quite large, and it's supposed to serve as an introduction to using sensors, motors, and actuators with LabVIEW and MyRio, specifically in regards to these boards as well. So there's going to be detailed instructions for how do you actually set up the MyRio hardware and the drivers and get LabVIEW up and running on your computer. And there's incredibly detailed introduction to LabVIEW in general. So you're looking at LabVIEW terminology, how the UI works, and how you use the graphical programming language. I've looked at a lot of different tutorials for LabVIEW over the years, and this is one of the most comprehensive I've seen. It covers a lot of information, and it's very helpful. Even for somebody who might be familiar with LabVIEW, there's a lot of good information. And then lastly, it also draws some parallels between text-based programming and LabVIEW programming. So it kind of looks at the difference between using a graphical programming approach and how does that relate to, or how is it analogous to different features within text programming language, for instance, like the C programming language. So the courseware breaks into, not only is there an introduction to LabVIEW and getting your MyRio up and running, but then it dives into sensor board exercises. So there's a number of exercises, and you'll look at reading data from analog sensors, doing digital input-output. You'll look at pulse width modulation, using a serial port, using the I2C bus, using the SPI bus, and doing orthogonal coding. And there's even more stuff. I just didn't have enough room to list everything here. So we'll take a look at kind of big picture, what some of these modules look like, and the sort of things you'll be learning with it. So in the analog labs, you'll be graphing data from a photoresistor, and I'll show a quick demo of that after I finish the rest of this slide. And you'll also be graphing distance measurements using an infrared rangefinder. You'll look at graphing temperature changes using a thermistor, and then using the 2D rocker control, which is down here. So moving this on the x-axis and reading an analog response from that. And within all these labs, I want to reiterate that it's not just a step-by-step instruction that is included, but it's also trying to serve a purpose of discussing, what is analog, why is that useful, how do we actually get that data, and how do we actually graph that data out. So there's a lot of information that is beyond just step 1, step 2, step 3. And to kind of give you an example of how this works, I'm going to go ahead and show you a demonstration of the photoresistor lab. And I have a lot of moving parts here, so bear with me for a moment. I'm going to open up a new VI in LabVIEW. And the VI in LabVIEW is basically a program for people who maybe haven't used LabVIEW before. And in here, I'm going to create all of my different, basically, functionality and my front end. So to actually do this, what I'm going to do is on the block diagram, I'm first going to go to my MyRio tools and take an analog in input. And this will basically allow me to grab like an analog pin from the sensor board and use that to get data from. And that's going to load. Hold on, I need to clear up my second monitor here. I always have a reference page on my other monitor. And then on the front here, I'm going to make a waveform chart. So we'll be able to basically see the photoresistor's resistance over time. And then on the back, I just need to fill out the rest of this. And what we'll do is make a while loop so that we can loop through this program until I press the stop button, which I'll create right here. And otherwise it will just loop forever. And then I can connect this analog data to the waveform chart to basically graph the data out. And one other bit I need is a the reset node, and this will handle any well, it will handle errors, but it will also ensure that when the program stops running, the MyRio will basically reset itself back to a base state, so we don't get any issues. And then we're going to do a wait for 100 milliseconds here, and this will basically just allow us to ensure the time steps that we want constant, that we want to be taking our data at. So we want to be taking data at 100 millisecond time steps basically. And then in here, I'm going to move my stop button over slightly, and let's go ahead and save this, and I'll run it, and then it's going to compile and build everything. And after a few moments, it should start running, and I'm getting data. Now let me turn on my camera so that you can see me do this. And one other thing, I need to set the focus. Okay, so on the board, my photoresistor is right here where I'm pointing my finger, and you can see on the left, as I'm kind of putting my finger over and away, you can see the resistance changing based on the light. So a photoresistor is basically measuring light intensity. It's obviously more complex than I just described it, and the courseware actually describes how a photoresistor works. So you'll kind of talk about that, but we can see how it's changing over time. Resistance goes up when I kind of cover the light, and then goes down when I pull away from it. So that's a very simple example. This is, I think, the first lab that you actually do in the courseware. So it's pretty introductory, and it gives you a good look at how to use LabVIEW and the sensor board as well. So with that being said, I'll go ahead and close that out, and we'll move on from there. So we'll also, after the analog labs, you'll go into digital input-output labs, and in here you'll be looking at controlling LEDs, doing a relay control with the relay that we see down here at the bottom right. We'll do a touch switch experiment using this here, so you'll press on this and basically turn on and off a control in LabVIEW, or an indicator in LabVIEW, I should say. And we also have a toggle switch like this here, so you'll switch this on and off to turn on a series of LEDs. And then a rocker button experiment where we'll use the rocker again to actually use the digital input, which is when you push in on the rocker, it sends a digital signal. So we'll look at manipulating that. And again, with the digital I/O labs, we're not just looking at step-by-step instructions, we're also looking at what are each of these tools useful for, and kind of what's the difference between, say, digital and analog. From there, you'll move on to PWM Labs, so pulse width modulation, and the chapter will start with a overview of what is pulse width modulation, what's a duty cycle, how does the frequency affect the signal, and yeah, all the details about pulse width modulation and why it's useful. And then some of the experiments you'll do are a 3-color LED experiment where you'll make this kind of front end on the bottom right here, where you can control the red, green, and blue value going to this LED that we see in the center here. So you can basically make a lot of different colors using pulse width modulation. And then we also have a buzzer experiment, and this is the buzzer here on the bottom left, where you'll create a front end interface that looks like a musical keyboard. And when you press those keys, it will send a frequency signal to the buzzer to output that frequency as sound. So this will explore some details of pulse width modulation, and from there you'll move into the I2C labs. So here you're going to explore what is the I2C bus, again, why is that useful, what kind of applications is that used in, and some of the experiments here are a 9-axis gyroscope experiment, a digital light intensity sensor experiment, and display control button recognition experiment. Now that we'll move on to the motor board exercises, but I also want to emphasize that those aren't the only sensor board exercises. There is more stuff, but for the sake of time, I don't want to include every single thing from the courseware, but those are just some of the big ones, some of the highlights, and kind of the first few that you'll run through, and then you'll move on from there to other topics. So now we'll move on to the motor board and kind of look at what the courseware has to offer for this. So the main things are that we'll have a stepper motor motion control lab, a steering gear motion control, DC motor control, a solenoid valve electromagnet control, and a digital tube display control exercise. Now in the stepper motor labs, we'll be looking at what is a stepper motor, how does that differ from, say, a DC motor, and why is this useful? How do we interface with it? And, all the details that you need to know. And so you'll be looking at doing forward and reverse experiments, controlling rotation speed, controlling a rotation angle, as well as doing acceleration, deceleration control. And then you'll also look at doing DC motors, and just like the other labs, you're going to talk about what is a DC motor, what is that used for, how is it different from the other motors, etc. So with this lab, you're going to be looking at doing a DC motor forward and reverse. You'll be controlling speed in open loop, controlling doing speed detection, so analyzing like RPMs, for instance, checking motor speed in a closed loop, and doing motor position in a closed loop. And then you'll also be using an encoder and pulse width modulation in this lab. So continuing on from the sensor board's pulse width modulation labs, you're going to be now using that in the DC motor lab, and then you'll be using an encoder to determine the number of pulses that have basically been registered. So I'll show a quick demo of this now to kind of give you an idea of what the motor board's like. And let me get my complicated setup going here. Now I need to switch these boards over, so generally what I do is I unplug power to make sure I don't screw anything up, generally best practice. And so I'm going to remove these ribbon cables and basically swap this to the motor board. And I want to emphasize that you can actually plug in both boards at the same time. I'm not doing that here, but that is a possibility, so that we could actually work with both boards doing some interesting experiments that way. So now that this is plugged in, I also need to run my power supply into this, and I'm going to make sure that's set to off, and then plug it in, turn this on, and my light's on, so I should be good here. Now let me open up my lab view. Lost connection to my Rio, and that's normal because I just unplugged it, so I need to reconnect it. So back here in my projects, I can connect, and then it's going to go through the process of grabbing the my Rio. Oh, I forgot to plug it back in. That is my mistake. There we go. And I'll cancel that and redo that. And as I do this, let me get my information here. Okay. All right, looks like it's still trying to connect. Okay, that took much longer to connect than I think it should have, but we made it. All right. So then what we're going to do is open the DC motor VI, and we're going to open up our block diagram so we can go to the back end here, and we're going to come into here, and we're going to choose the PWM node for the MyRio. So this will basically say that we want to manipulate a PWM pin on the board. And we're actually going to end up having two of these, one to control the speed of the motor and one to control the direction. So we're going to set this to a constant 1000 Hertz on pin 29. And then we're going to actually put in another one on pin 31. So these are the two pins essentially associated with the PWM signals that we want to use. Again, we're going to do 1000 Hertz for the frequency, and then we're gonna have a control that dictates the duty cycle. But before we do that, we also want to put an encoder in here to keep track of the number of pulses that we've run through. And on the encoder, we just leave all this default. And then on the rest of this, it should be pretty straightforward. Let's go ahead and make a loop. Generally in LabVIEW, you almost always make like infinite loops around your programs, well, at least most of the time that I use it. So then we're also going to connect to the duty cycle here. We're going to create a control, which is going to be the motor speed. So this first one should be controlling the speed of the motor, and this will show up as a numerical input on the front panel. We see right here that as I created that on the back end, it shows up here on the front. And then for this one, this will be the motor direction. We're going to create another control here, and we'll call it motor direction. Kind of get that organized. And then here we're going to output the value onto a indicator. And so this will actually display the number of pulses from the encoder. Now, what we do here is we also want to connect our air outs to the MyRio reset. So I'd mentioned in the sensor lab that we always do a reset node here. And what we'll have is the air out connects to the air in here. This air out goes here, and then this air out goes here. So this will basically trickle down. If we have any errors happen at any step of the way, we'll trickle that air down into the reset and basically ensure that we're safe as far as our execution is concerned, so that we don't get some undesired behavior. Now with that, I think that's okay. Let's go ahead and save that. And let me kind of move these around. So I'll have motor speed and direction. Do my stop button kind of over here. And then my counter value, which will be my pulses. And one thing I also want to do is change the step size for these buttons. And it's not letting me. I think it's data entry. Ooh, that's weird. Okay. Well, my properties thing is not coming up. Apparently my lab view is bugged. I'll have to troubleshoot that later. So I'll just go ahead and run this and bring up my, I need to save everything first, and then let's bring up my camera again. And let me refocus, and then bring up lab view here. Bring that down. Got to move all my stuff around. So the DC motor is this right here. And if I turn the speed up, we can see it starts turning. And so I labeled these wrong. The motor speed is actually the direction, and the direction is actually the speed. And I can only go in one value increments, so I can't do like fine control right now, but you can see how when I switch this to negative, it starts rotating the other way. If I switch it to positive, it starts rotating. From my perspective, that's counterclockwise, and then the negative is, from my perspective, clockwise. And then we can see how the pulses are being registered in the counter value here. So as we go negative, positive, you'll see this value change. So that's a very simple example of the motor lab and kind of what you can do with it. And this is a rather quick one where there's only a few blocks and the logic makes sense. It's pretty straightforward. So just take, and let's see, that should be it for that. Making sure all my stuff shut down properly. I'm going to turn the board off. Okay. So after the DC motor, there's also a couple of other motor labs, like working with a servo, but one of the fun ones that I found when I was going through the courseware was the doing all the motors at once. So you end up making a front panel like this, where you basically have control over the stepper motor, the DC motor, the servo, and being able to manipulate all of them at once. So that's kind of a fun lab to really explore all the different motors and the technology behind it. Again, I want to emphasize that this is not all of the exercises in the courseware. This is just a look at some of them. And I also want to emphasize the point that the fact that we have LabVIEW here and the MyRio gives us a lot of possibilities with all these different sensors and motors. I mean, LabVIEW enables you to really do any sort of data analysis, do a lot of manipulation with the different sensors and motors, and the MyRio will serve as your base to interact with all of that. So Really, the tool is just great for research, experimentation, any sort of custom training, and it's also great for learning, how to use all these different sensors and motors. So the pool of potential projects is really limitless because you have so many different devices here to work with, and it really just comes down to your own imagination, ingenuity, how you want to use the tool. So, LabVIEW is going to enable a lot of potential projects with these two boards. Now, with that being said, I'll go ahead and open it for questions. You're all still muted because I don't want audio feedback, but if you do have a question, please use the chat menu. Again, I talked about this at the beginning. Some of you might not have been here. The chat bubble is the second bubble on the left of your Join Me panel at the top of your screen. If you type in there, me and my colleague Christy Leitner are going to look at that, and we can hopefully answer your questions. If there's a question we can't answer, we'll probably take your information, try to get in touch with you afterwards with an answer to that question, but feel free to ask anything. And hopefully we can do our best to answer that. And while I wait for those questions to come in, I'll go ahead and look at the further information here, basically contact information for Studica. If you need to talk to us for any reason after this, you could reach us at sales@studica.com to reach sales representatives who are generally very knowledgeable about our products. They're also very knowledgeable about navigating school funding and things like that. So if you do have questions about anything, feel free to reach out to them. You can also reach us by phone at 888-561-7521, and that's available Monday through Friday, 9 a.m. to 5 p.m. Eastern Standard Time. And you can just call us and talk to somebody directly if you prefer. And I also want to point out that there's a follow-up email that will be sent with more information about this kit, and it will also include a recording of this webinar, so if you need to show this to anybody, feel free to do so. Let me look here at the chat. Brian had to drop. Okay, so I'm not seeing any other questions. So again, if you think of any questions, feel free to reach out to us afterwards. If not, thank you for joining us today, and I hope you all have a good day and a good rest of the week. Have a good one. Thank you.